In this video, we will learn about electric current. We will learn how to measure electric current using multimeter. We will also learn all these concepts with respect to an Arduino Uno. We will learn how to make electricity, and we will see that what will happen if we provide more current to an LED. On this planet Earth, we have seen lightning or northern light. All these are physical phenomena of electric current. We can even make electric current at our home. So take the alligator clips, 12 volt DC gear motor, LED, connect the DC gear motor with the LED using the alligator clips. So now if you see that when we rotate this DC gear motor, you will see that the LED will glow. Let's see another method to produce electric current. Take the piezo buzzer, open the piezo buzzer, you will see that there is a piezoelectric disc. So connect the positive terminal of the LED with the red wire of the piezo buzzer and connect the negative terminal of the LED, the shorter leg of the LED, with the black wire of the piezo buzzer. Now if you tap the piezo disc, you will see that the LED will glow. So this is how you can also produce electricity. So in order to understand electric current, let's see what is inside the atom. An atom consists of electron, proton, neutron and nucleus. So nucleus is present in the center of the atom. Proton and neutron are present in the nucleus and electrons are present in the orbit around the nucleus. There are some free electrons in the outermost shell of the atom. So if I talk about the copper wire, there are some free electrons in the outermost shell which moves in a random direction due to thermal energy. And when we apply the voltage across the conductor using the battery, these electrons start moving in particular direction. And the movement of this electron is called an electric current. So we get current by placing voltage across things. So if I place the battery in the circuit, we get the voltage from the battery. And we can see that the LED will glow. So this voltage source applies the electric field in this circuit, and because of this electric field, the electron starts moving. And this flow of the electron is called an electric current. So if I formally define what is electric current, it is the rate at which the charge flows through a substance. So here charge can be electron or it can also be an ion. So if I talk about the human body, our brain, neurons or nerve cell uses ions like sodium ion, potassium ion, chloride ions in order to communicate information in our body. So these neurons or nerve cells uses electric signals in order to communicate inside our human body. So just like we measure temperature in degrees Celsius, same way we measure electric current in amperes or milliamperes. So 1 milliampere is equal to 10 to the power minus 3 amperes. So the formula for electric current is I is equal to Q by T, where I is electric current, Q is charge and T is time, or I is equal to dQ by dt. Let's learn how to measure electric current using multimeter. Take the battery connector, connect the red wire in the first row and the black wire in the second row. Now take the LED and remember that the positive terminal is the long lead and the negative terminal is the short lead of the LED. So connect the resistor with the positive terminal of the LED and the power supply, that is the battery first row. Now connect the negative supply of the battery into the negative terminal of the LED. Now connect the battery. So this is exactly the same circuit which we have seen in the previous episode. Now remove the battery and take the multimeter probe, connect the red probe in the V ohm milliampere terminal of the multimeter. Take the black probe of the multimeter, connect in the COM terminal of the multimeter. Now in order to measure electric current, we have to break the circuit between the positive supply of the battery and the resistor. So after breaking the connection, we have to connect the red probe of the multimeter in the positive supply of the battery and the black probe of the multimeter with the resistor in series. So this way we can measure the electric current. So first connect the jumper wire in the first row so that we can connect the red probe of the multimeter easily with this jumper wire with the power supply. Now set the multimeter on 200 milliampere of current. Since we know that the LED take only small amount of current, so we will never exceed the current in this multimeter above 200 milliampere. So this is the safe range. Now connect the battery in the battery connector. Now we have to connect the red probe of the multimeter with this jumper wire which is connected with the positive supply of the battery and connect the black probe with this resistor. So now we can see that the LED is taking around 17.2 milliampere of current. So this way we can measure our electric current. So now make the connection as the initial circuit. So this is the initial circuit which we have made. So we have to understand that the resistor limits the current throughout the circuit. So we can even measure the current by breaking the circuit between the resistor and the positive terminal of the LED. So we can connect the red probe of the multimeter with this resistor and the black probe of the multimeter with this positive terminal of the LED. So now also we are getting the same reading, that is our LED is taking around 17.2 milliampere of current. We can even measure the electric current by breaking the connection between the negative terminal of the LED and the ground wire. Connect the red probe on the negative terminal of the LED and the black probe on the ground wire. We can see still that there is same reading. The LED is taking around 17.2 milliampere of current. So it's important to understand that the resistor limits the current throughout the circuit, and in order to measure current we have to connect the multimeter in series always. So now remove the battery, and after that set the multimeter at the off state. So this is how we can measure our electric current. So now we will measure electric current of the electronic component which are connected with the Arduino Uno. So for now, focus on the understanding the concept, not on the circuit. We will see the circuit in future video. So for this circuit as well, the concept is same. We have to break the circuit and connect the multimeter in between in series with the circuit element for which we want to measure the electric current. First, make the circuit, connect the black and red probe as shown in this video, set the multimeter on 10 ampere and connect the USB cable in your laptop. You can see how much current is taken by the servo motor on this multimeter screen. So we will be using multimeter throughout the course. So I recommend to buy this multimeter, it's very cheap. After measuring the electric current, first remove the USB cable from the laptop. After that, set the dial at the off state. So now let's see another example in which we measure electric current of an LED connected with the Arduino Uno. First make the circuit, after that set the multimeter on 200 milliamperes. After that connect the USB cable in your laptop, then connect the probe as shown in this video. You can see that this LED is taking around 9.2 milliampere of current. So there are two types of electric current, the AC alternating current in which the electric charge periodically reverses direction. In this the charge move in forward direction as well as in reverse direction. So we get AC current in our homes in main supply. There is another kind of current, that is direct current, in which the charge flow in only one direction. So we get DC current from batteries or AC to DC adapters. So the laptop chargers we use inside our home, that also convert AC current into DC current, or the phone charges that also convert AC current into DC current. Even on microcontroller, all the integrated circuit works on the DC current. So if I talk about the current in respect to Arduino, the maximum current per IO pin is 40 milliampere. If we see on the Arduino official website, it's written it's 20 milliampere on the safer side. So we should never exceed the current more than 40 milliampere, otherwise you will destroy your board. So we should never use the load like LED which is using more than 40 milliampere of current, otherwise we will destroy our Arduino board. So this current is very small. This current cannot be used for driving high current loads like motor, but this current is enough for generating control signals. So the maximum current on 3.3 volt pin is 50 milliampere. The maximum current on 5 volt pin is 500 milliamperes. So electronic component like wires have current rating. So the thicker wire can handle more current and the thinner wire can handle less current. So if you provide current more than the current rating of the wire, it will overheat, it will burn. So you should never provide current more than the current rating of the particular electronics component like wire. So every electronics component like wires or resistor or power source have the current rating. Let's see this. In this we are slowly increasing the current on the LED and we are measuring the current of the LED using the multimeter. So this LED can handle 20 milliampere of current. If we provide more than 20 milliampere current, either the LED lifespan will reduce or we will immediately destroy our LED. So let's see this, what will happen. So now our LED is taking too much of current. So now you can see that our LED is destroyed. Now we cannot use this LED anymore. So if I connect this LED directly on this 9 volt battery, also the LED is destroyed. That's why we use resistors. So in summary, the flow of electrons is called electric current. It is measured in ampere or milliampere. While making the project, we will be mostly dealing with milliamperes of current. Every electronics component has current rating, we should not provide more current than the current rating. Maximum current per IO pin is 40 milliamperes. This current is suitable for turning the LED on or generating control signal, but it's not enough for high current loads like motors. For driving high current loads like motor, we will be using MOSFET or BJT. So that's the another topic which we will be covering in the future video. So if you find this video helpful, please share the video, like, comment, subscribe the channel. This will really motivate me for making more good content for you. So we will be meeting in the next video. Bye bye.